Welcome. Today I wanted to spend a little bit more time talking to you about dimensional analysis as you continue to work on your Dimensional Analysis Olympics. As you know, you were given and started an activity on Friday of this past week in which you were asked to complete some tasks in which you were going to use some information provided in the process of problem-solving skills along with calculations and dimensional analysis to figure out how to work through the information that you're given. So let's just take, I thought that the next station we could do, I had done station 3 with you to kind of help you set it up on Friday of last week, and now I wanted to look at station 5 with you and give you another chance to kind of see what it should look like as you are, completing the task. Now, y'all, again, I'm going to reiterate to you that I'm not going to show you exactly what to do, and I'm not going to tell you exactly what to do. I've given you a process of dimensional analysis. If you've been following along in class, if you've been asking questions, if you've been paying attention as we went through the station on Friday, then you've seen all that you need in terms of understanding the skills, understanding the steps you need to follow, and now it's up to you to start pulling it and putting it together. So I won't show you exactly what to do for all stations, but I will guide you in where to get started and what information you need and all of that. So let's just take a look at station 5. Now station 5 says cardiac output is the total volume of blood pumped by the ventricle per minute, or the product of your heart rate and your stroke volume. The stroke volume at rest is the standing position averages between 60 to 80 milliliters of blood in most adults. If your stroke volume is 70 milliliters, how many liters of blood would your body pump in 1 minute? Now there's a lot of information there, and this is why I wanted to do this problem, because this problem actually is a dimensional analysis problem, but it's also a other kind of calculation like we had talked about where you're simply solving for x. So let's simply take a minute and let's just talk about x for just a minute. Starting with, based on the information we're given in this problem, we're being told that cardiac output is volume of blood per minute. And if you'll notice in our question, it even asks us right here, how many liters of blood would your body pump in 1 minute, right? So that question right there, that's really just asking for the cardiac output. So, if we wanted to, we could even go ahead and say that is our unknown, right? We don't know. We don't know what the cardiac output is. That's our question, right? Just like we talked about in all of our dimensional analysis problems, the question is always the unknown. All right, so let's go back. Cardiac output is the total volume of blood per minute. And then it goes on to say it is the product. Now, I'm going to just go ahead and write CO for cardiac output just to abbreviate it. So cardiac output, or CO, is the product of your heart rate, which it writes as HR, and stroke volume. Now remember, product really just means like saying times, right? To take things times each other. So this is saying that cardiac output, CO, is what? Is the heart rate times your stroke volume. Now remember, you're trying to figure out cardiac output, right? So you're trying to figure out cardiac output, and we'll get to that in just a minute, but it tells you it's the product of your heart rate and your stroke volume. It goes on to say in the problem, the stroke volume at rest in the standing position is between 60 and 80, and then it even tells you what your stroke volume is going to be, right? So your stroke volume is 70 milliliters, okay? And it says, how many liters of blood would your body pump in 1 minute? Well, let's just start with, how do we figure this out? How do we get to cardiac output, which is the volume of blood per minute, if we have a stroke volume? Now, we're missing one other thing, and so this is where your measurement is going to come in. So you're told your stroke volume is 70, but you don't know what your heart rate is, but that is something that you could measure, right? You can measure your heart rate. How would you do that? Well, you would simply take your heart rate. For those of you who haven't done it, you could do it a couple different ways. One, you could simply take your heart rate over a minute and see what it is. So see how many times your heart pumps or beats per minute. A couple ways you can do that is you could take 2 of your fingers and put them at the base of your neck and feel for your heart rate there. You could also even do it by taking 2 fingers and putting them on your wrists and feel for your heart rate there, and you could count that for a total of a minute. You could also count it for 10 seconds and then take it times 6, right? Because if there's 60 seconds in a minute, if you count it for 10 seconds, you could take that times 6, and that would give you your heart rate for a minute. Well, I went ahead and did it for myself so that we could figure this out, and so I got that my heart rate was 56 times per minute. So my heart beats 56 times per minute, right? So, or I'll just say 56 per minute. And I want to know what my cardiac output is. So what is cardiac output? Cardiac output is heart rate, which is 56 times per minute, times my stroke volume, which we said was 70 milliliters. And I could figure out what my cardiac output was. So go ahead and take a minute and see if you can figure out what my cardiac output is based on that. Simply put, it's the product of my heart rate times my stroke volume. So my heart rate was 56, my stroke volume was 70, and I got 3,920 milliliters per minute. All right. Now that's great. That gives me my cardiac output, and that's what the question asks. But the question actually asks for liters. So right now I've got my known. Alright, now this was a little bit different problem because I had to do some work to figure out what my known was. But this is my known. I know that my cardiac output is this many milliliters per minute. Now remember my question or my unknown we decided was what? We decided it was liters per minute, right? So liters per minute. And the question is, how do I get to that? And that would just simply be through dimensional analysis. So what's the relationship between milliliters and liters? Well, that's pretty simple, right? There's 1,000 milliliters in 1 liter. So from that, my conversion factors, right, are 1,000 milliliters over 1 liter, or 1 liter over 1,000 milliliters, and then it's a matter of plugging it in. Which conversion do I want? Well, I want to get rid of milliliters, so 1 liter over 1,000 milliliters, and liters is left over, so 3,920 divided by 1,000, and I end up with 3.92 liters. Now, based on sig figs, really, I probably should have rounded, but I'm just going to go ahead and leave it at that, y'all, for the sake of what I started with. With sig figs, I probably should have rounded this to 1 to begin with, and that would have given me 4,000 milliliters, and then that would have given me 4 liters. But since I didn't say anything to you about it as I was doing it, if you had not rounded, that would have been okay. Alright, but that's it. So as you're looking at this, simply put, this problem was a little bit more challenging because it asked you to pull some information out, but that's what your problem should look like. Now, how do you go back and how do you transfer that to your own? Well, look, the only thing that's going to change for you is going to be your heart rate, because you're going to have to do this for yourself. So do your heart rate, plug it in, and then start solving for your cardiac output. If you should want me to look at your work, please feel free to take a picture of it and text it to me in Remind, and I'd be more than happy to take a look at it and tell you how you're doing and where you're going wrong, or just tell you that you're doing a great job. So if you should have any questions, please don't hesitate to ask. Please know that this week I am going to be at school today. That is Monday. If you should need any extra help, please feel free to stop by and see me after school. Otherwise, that will be the only day I'll be at school this week, and then next week I'll be back at school on Thursdays. I think that's it. I hope you have a great day. Again, let me know if you have any questions. Please continue working on this. Please make sure that you complete all of the stations, and and that if you get stuck on a station, that wherever you get stuck, that you ask questions based on that. But please do not just say, I don't understand, because that makes it really hard for me to help you out. So please show me the work you have, and I can guide you on where to go from there. Thanks. I hope you have a great day.